little reminder about what we did regarding convergent lens. Then we'll talk again, show the principal light rays for divergent lens. And I want to point out the difference, because I've noticed in the past that people seem to like a lot convergent lens and they don't like divergent lens. And when asked in an exam to draw the principal light rays for a divergent lens, a lot of people end up drawing the light rays for convergent lens, which is very different, right? So I want to point out what's the difference. So you remember, if you have a convergent lens, I show you that the convergent lens has this property that parallel light rays coming from one side, they get focused onto one point, they converge to one point. It doesn't mean that their light rays are going to stop there, of course, they just continue going. But they, at some point, at that point, they just cross. Everybody cross at that point. So just that basic property, that seems a curiosity, it turns out to be very important, because it actually makes an image of an object. Whenever you put an object in front of a lens, the lens will make an image of that object. And that image has a, remember that it has the requisite that one point on the image has to correspond to one point on the object. If that's not true, then there is no image, right? If light rays coming from two different points of the object can reach the same point, that is bad. That is not an image. It will look blurry at most. Okay? So lenses have that property, very special property. So one of the light rays, knowing that property, knowing the fact that that I just mentioned, then if you look at the light rays coming from one point of an object, this is your object here. That tip of the object, we usually focus on that tip of the object, but we could have chosen a different point on that object and do the same thing. That object is shooting out photons in all directions. They hit the lens, they get diverged to some point, and so on. But let's just do the tip one, because that's going to give us information about how big is the image. That's the main reason for that. So the parallel light ray goes through the focal point. That photon is going this way, hits the lens, and it gets deflected that way. And it keeps going, of course. Then the one that hits the middle, the light ray that hits the middle, nothing happens to that one. The light ray that hits the near focal point, right, then turns parallel on the other side, right? So there is this light ray that comes parallel on this side and crosses the far focal point, and the one that crosses the near focal point turns parallel on the other side. Story is going to be reversed when we do divergent lens, so keep that in mind. So that's how you do it. Now what for a divergent lens, the divergent lens does something different to light rays, to parallel light rays. Instead of sending them to one point, that's the other focal point. It has two, as before, the near one and the far one. And if you have your object sitting over here, then you want to, one of the principal light rays is going to be parallel again, just like before. You want to look at what happens to parallel light rays when they hit a lens. That's one of the principal light rays. But that one, instead of going towards the far focal point, it actually diverges in a way that looks like it's coming from the near focal point. You can do your dotted line in the notes. I just do that with blue because I can't do the dotted in the iPad. So that is, notice the difference between this light ray and that light ray. In a convergent lens, it goes through the far focal point. In a divergent lens, the light ray seems to come from the near focal point. The one that goes through the center, the situation is the same as before, because at the center, the lens surfaces are parallel to each other, so they cannot change the direction of a light ray. And that just keeps going as before. And you already know where the image is going to be located. But you could do a third one, and the third principal ray is going to be the one that heads towards the far focal point. It's heading that way, but it never quite makes it, because it finds a lens in its way, and the lens is going to tilt it this way and make it parallel to the optical axis. So to an observer over here, seeing these light rays diverging that way, that observer is going to see the image of the object as being here. Okay, a light ray that comes from this direction seems to have originated from here. A light ray going that way seems to have originated here. A light ray coming this way. So the image of that object will be located there. So notice the inverted role of near focal point and far focal point in these two kinds of lenses. That's a very big difference in the way those lenses form images. For a lens like this, a divergent lens, you see that the image seems to be always in front of it. No matter how you draw these rays, no matter where you put your object, the light rays, when you draw the one that goes through the center is going to go that way. The one that goes parallel is going to diverge in some way. If you think about it carefully, you'll notice that for a divergent lens, the image is always in front of the object. Another important thing to notice, both for converging and divergent lens, is that the image is always along this line. Image and object are along this line. The light ray that hits the center of the lens sort of tells you already where the image is going to be located. The image in both cases is going to be somewhere along this line. Okay? For a converging lens, you can have images on this side of the lens. So they're going to be inverted, you already know that, but the tip of the object is going to be along this line that connects the tip of the image with the tip of the object. Okay? You notice it here also. Right? Let me draw the image up there and draw the same red line. Okay, so along this line, as I said, you find the image. In the divergent case, you find the image always on this side, which means that it's going to be upright. That means in the same orientation as the object, and it's going to be smaller, because if you put an image in front of this one, given the fact that it has to be within this line, then it's going to be always smaller. But for the converging case, the image can be formed anywhere on this side of the lens, and therefore your image can be smaller. It's going to be inverted up to a certain point. We'll talk about that in a second. But it can be, if it's really far away, then it's going to be bigger than the object. Okay, so that seems pretty clear by looking at this line.